kind of graph would this create if I were to graph it? Just forget the greater than, just this part. Parabola. Because it's an x times an x, it's an x squared, it's a parabola. What would the x-intercepts be? What are the zeros in the function?
3 and negative 4.
3 and negative 4. So that means it's going to cross the graph here and here. 3 and negative 4. So you can kind of imagine, we're not graphing this, by the way. We're not graphing. But you could imagine the parabola looks something like this, right? Okay, but this is an inequality. The answers are not 3 and negative 4. The answers are, where is this function value greater than 0? So on the graph, where would the function value be greater than 0? Okay, well, the function value is like the y value. So the y value is greater than 0 from negative 4 to the left, well, to the left of negative 4, so less than negative 4, and from 3 to the right. Like, for example, when x is 4, the function value will be a large positive number. Or when x is negative 5, the function value is a large positive number. So when it says greater than 0, it's basically asking where is this function value positive, and that would be when it's above the x-axis. You guys follow that? Of course. Yeah.
I got a root beer, Mr. Jordan.
You got a root beer.
You got a root beer. They're stealing Mr. Jordan.
What's you want in case of emergency.
Mr. Jordan's not wearing a gazillion views.
Can I dare you to scream?
Dude,
I'm a Christian.
if he says who did it, we're blaming it on Shelby.
No, Shelby's too slow.
She's not kidding.
You watch it. You're watching it. It's true. Am I wrong?
Okay, yeah, we'll blame it on Easton.
Say you have a gazillion views.
I'm not gonna say it.
Mr. Jordan! Can't be sorry.
It's the shoe. We have you just died.
Oh, he's good. Wait.
Mr. Freak.
Can't do that. Oh,
You got the
Got one.
Oh,
Yeah.
Hey, have a big drink.
The world's tiniest beach.
No, that's huge.
It's like those candy jars. Like the two singular ones. Yeah.
I hate to break it.
Seven. Like 2.
It's just the way you were freaking out. You're like,
Rick, not invited to a freak off.
That's how you freak off.
We're in the prison.
Not invited to
Prison
freak
freak
off.
off.
Bro, it's not a member of the community, bro. Yeah.
What the heck were we talking about?
Freak Diddy. You can't pull us to a freak off like that.
Okay, so here we go. What x values make this function greater than 0? So everything to the left of negative 4. So that would be x values less than negative 4. Or all the x values to the right of positive 3. So x is greater than 3. You guys follow that? So when x is negative 5, negative 6, negative 7, the function values are going to be positive. Or when it's 4, 5, 6, it'll be positive. So this would be the answer to number 1. Does that make sense? I always, this usually does confuse people, and I always don't know why. I'm always lost. Okay, here's the other way you can do it. If you can recognize negative 4 and 3 are the x-intercepts, like 3 and negative 4, you can check to see where the function values are positive or negative. So if you plug in your calculator like -5, something positive will come out. Like if I plug in -5 here, I would get -8 times -1 is 8, which is greater than 0. So I would get a positive value. So that tells me the function is positive to the left of -4. Okay, if I plug in something in this region between -4 and 3, like 0, if I plug in 0, I get -3 times 4, which is -12, which is negative. So that tells me that between -4 and 3, the function value is negative. I think it's easier to just, like we did last chapter, just know what the graph looks like. Like, is it a squiggle? Is it a W? Okay, but if you can't remember or you're not sure, you can just plug in the values between, like around these x-intercepts. Because the graph's going to be crossing over at this point from positive to negative or negative to positive. So if I plug in 4, positive 4, what should I expect to get? I should expect to get a positive value because the graph is way up here. If I plug in 4, I get 1 times 8, 8. So when x is 4, so out here that tells me that the function is positive. Okay, that's if you don't use the graphic method. Okay, let's do, we got a lot more examples. You guys will pick it up. I have no doubt. Number 3. -1, -2, -4. So what are the intercepts on this one? 1, 2, and 4. So there's kind of nothing happening. So do you guys know? Oh, you missed the explanation.
Bro.
Bro.
Well, you're videoing, right?
So, okay, 1, 2, and 4. So what shape would the graph take on number 3 if it's like x, you know, whatever it was, -1, what shape would this take? It's the squiggle. Okay, it's positive, so positives go from low to high. So the graph is going to look like this. Okay, on this one, I think it also said x is greater than 0, right? Okay, so where is the function value greater than 0? What x values would make the function value greater than 0? So greater than 0 is where it's above the x-axis. Okay, you have the x values, that kind of tells you where, and then the function value is like the y value, it's up and down. So what x values make the function value greater than 0? Well, between 1 and 2,
Oh my gosh.
we might open that a little bit.
Check.
Just crack it open.
Just open up
That's
the whole way
good.
and release the air.
It was too cold. I was standing over there. You guys have jackets on, but anyways. So when the x value is between 1 and 2, you guys see how the function is above there? So how do I write that? Like this. X is greater than 1 and less than 2. So this is how you write x is between these two values. Or where else is the function greater than 0? Right. All the x values greater than 4, the function will be up here. So x is greater than 4. Okay, let's say I was like, I'm not sure I did that right. If this is true, I should be able to plug in 5 for x, and it should be true. If I plug in 5, I get 4 times 3 times 1, which is 12, which is greater than 0. So yeah, it is true. or if I plug in 1.5, because that's between these two, I should expect to get positive. Alright, you guys kind of get it? Starting to get it? Alright. Can you guys read this? Is it showing up well enough?
I should join them this year, 2 days.
It is. You don't have to ask. It is already, but that was number 3, right?
Yeah.
Huh? These things?
Yeah.
Well, it's kind of like, remember on a number line, like if it's like this, what's this called? X is greater than 4. So up here, all the x values over here make the function greater than 0. So it's x is greater than 4. And if it's between two values, it'll always follow that pattern.
But why isn't it between the 2 and the 4?
Okay, between 2 and 4, the function value is negative because it's below the x-axis. Now, if the sign switches, then we would have to put between 2 and 4 because greater than 0 means we want where the function is positive, and then if they switch it to a less than, we want the opposite. We want where is it negative. All right, number 5. -4, -2, -3. All right. What is the degree of this function? Actually, we don't even need that. What is the degree of this function? 5. What shape? Because you guys know where she got that from. There's 1x. There's 2 x's, like x squared. There's another 2 x's, x squared. So if we eventually multiplied all these together, we'd eventually get an x to the 5th. You guys remember what shape x to the 5th?
Is it like an M?
Okay, no. X to the 3rd was this. All odd powers are going to follow this pattern. X to the 5th is like that on steroids. So it's like that. Okay, but what's going to happen at 2 and 3? It's going to bounce. It's not going to go through, so 2, 3, and 4, I guess. So 2, 3, and 4 are the magic spots. But right there, we're going to come up against some resistance, right? So starts down, comes up. So bounce, bounce, go through. Almost. You're almost right. Okay. So I think what the book wanted you to do is like plug in like 2.5 for x and see like if I plug in 2.5 up here, does it give me a positive or negative value? I just think since we already did the graphing on this, this is faster to use a picture. And we don't need graph paper, it's just a sketch. You could even, if you wanted to, I wouldn't mind if you got out the graphing calculators to look at it, but yeah, that would kind of take a while too. This is kind of the fastest way to do it. Okay, anyways, we want less than 0. Where is the function less than 0? So where's the function below the x-axis? Well, almost all of these points are below the x-axis, except for right there and right there. It actually equals 0. Now, if they had put less than or equal to 0, we could have included those 2 points, but they didn't. So here's I could say the x value is between 3 and 4, the x value is between 2 and 3, and the x value is less than 2. But here's an easier way to say it. I'm just going to say all the x values from here and smaller, except for these two. So what is this x value? This is x equals 4. So I'm going to write x is less than 4, comma, but x cannot equal 2 or 3. I'm pretty sure that's how the book did it. Do you have to do it that way? No, it's just the easiest way to do it. Let's see, what number on 5? Yeah.
So it's like every number that's above the axis?
Okay. The function is negative when it's below the x-axis. So we're saying what x values make the function negative. So when x is less than 4, the function is negative because it's below the x-axis. But when x is 3 and 2, the function equals 0, so it's not negative. So those are like the exceptions. X can't be 2 or 3 though. So it's kind of like on a number line. Like all these values on the x are going to work, except for these two. So it's like x is less than 4, all those values will work. So if I plugged in like 1 or 2.5 into that function, hang it, where is it? If I plug in 1 or 2.5 up here, it should make this function true. It should make the value of the function less than 0. Because on the graph, this is where it's less than 0. X squared minus 2x minus. Okay, they did not factor it for us. So we're going to have to factor it ourselves. Suppose you could use quadratic formula. That's definitely the harder way. So what multiplies into negative 15? That adds up to negative 2. Okay, so I should expect the zeros of the function, the roots of the function, to be 5 and negative 3. Do a little rough sketch here. 3, 5. Okay, what shape does this take? X squared is a parabola, just like number 1. So it's pretty basic. Just gonna do something like that. Okay, I want the x values that make this function less than 0. On the graph, where is the function less than 0? From here to here, because this is where it's below the x-axis. This is where the y values are negative, which is like the function values. Where the y values are negative is where the function is negative. So where is that? Between when x is between negative 3 and 5. So how do I write that? Between negative 3 and 5. Yeah. You stand off to the side, it looks kind of gray and silver. When you look straight ahead, it looks white. Number 9, 2x 2x squared minus x minus 3 is greater than 0. Alright, it didn't factor it for us. So what goes into 2x squared is 2x times x. What goes into negative 3 is like negative 3 times 1. And we would need to put the negative 3 and the 1 like this. Because when you FOIL it, it'd be negative 3x plus 2x equals negative 1x. So what are the x-intercepts? What are the zeros of the function? What are the roots? They're all the same thing. Negative 1, positive 3 halves, which is positive 1 1/2. So I guess it doesn't really matter. Just mark it the same way. But it's just like the last one, it's an x squared. How do I know it's going up instead of down? Like, how do I know the parabola is going up? Yeah, if the leading coefficient is positive, it's going to go up. Negative, it's going to go down. Okay. Now, I need some audience participation. So we want, where is this greater than or equal to 0? Where's the function? Huh?
It's just great. No.
Or? Alright, we got one guy that gets it. You guys see where we got that from? The x values from here to the right give you a positive value. The x values from here to the left give you a positive. If I kept going, you know, this graph would keep going up forever. All these x values would give you a positive value. So it's x is greater than or equal to this, x is less than or equal to that. We start putting or equals to because they included it on the problem. Alright. We'll see if somebody besides Eli gets it. Number 11. 2x squared plus 5x minus 7. Okay, let's do some quick factoring here. Alright, what goes into 2x squared? 2x times x. What goes into negative 7? I think we'll need 7 and negative 1 because 7x minus 2x equals 5x. Okay, so our two zeros of the function are negative 7 halves. Okay, we don't really need to know where negative 7 halves is. We know it's negative, right? So it's somewhere over here. One's over here. So again, it's a positive x squared, so it's a positive parabola. Kind of the same thing. What's different on this one though is that it says less than or equal to as opposed to the last problem. So does anybody know besides Eli?
Negative 7 halves is greater than x is less than 1 or something. No, the other one. Other way. Oh, never mind.
This one?
Yeah.
Yeah, he said greater than.
Oh,
X is greater than negative 7 halves. Yeah. Yep, this is pretty much it, except for since they use or equal to, it can equal 0, so at negative 7 halves, that would be part of the solution. So use that. Yes, you got it. Good job, Hope. Two down. 15, x to the fourth. All right, you guys remember how these factor from chapter 1? Did you guys get this one right in the test? Okay, this is an x to the fourth function, so what shape will it eventually take? W. X to the fourth are W's. Okay, this factors, it's not a quadratic equation because it's an x to the fourth, but it's in the quadratic form because it goes x4, x2, nothing. So what goes into x to the fourth? What goes into negative 10 that adds up to negative 3? Negative 5 times 2. Okay, a lot of you got, if I remember correctly, almost all of us got like this part right, but then like solving to the end, maybe a few of us got wrong. We need this to equal 0 or this to equal 0. Because on the test, a lot of you, I think like 3 or 4 of you put like plus or minus 1 for this, which is wrong. It's kind of like this one. We need that to equal 0, so x would have to equal plus or minus I squared root of 2. Okay. On the graph, that's imaginary. On the graph, it's not gonna, there's no intercepts for this. So that basically tells me it's only gonna hit the graph twice, right here. Now it's possible there could be no zeros of the function, like nowhere, but of course we couldn't. Wouldn't be much to do with that. Okay. So on this one though, it's a positive 5. So when I take the square root, I get plus or minus square root of 5. Now where's that on the graph? Doesn't matter for these problems. We just need to know positives over there, negatives over here. Okay, it is a W, which means it looks like that. Doesn't really matter though, because it's only hitting twice. Is there any other way I could draw a W where it only hits twice? And the answer is possibly. It could look like this, but it doesn't matter because it would have the exact same answers. All the x values to the left are positive, and to the right are positive, and the ones in between are negative. It doesn't really matter how you draw it. The answer is going to be the same. All right, what do we want? Positive or negative? Positive. Issa, do you know what this one's going to be? Willow? No. Anybody else? No, you already did one.
Oh.
We know you get it. Okay. So, if it's positive, what should the graph look like? Where is it positive? What should it look like on the graph? Should be above. Okay, so that is this stuff. What x values describe where it's positive at? Okay, yes, all these x values. Now the graph keeps going, so all these x values make the graph positive. All these x values make the graph positive. So what are these x values called? Well, it's all the x values that are smaller than, just like on a number line. A negative square root of 5 like this, it's x is less than negative 5.
Why does the green have a shadow? Yeah, I see it.
But none of the other ones have a shadow.
I don't see a shadow.
It has like an outline almost.
It's orangey.
Yeah. It's like orange and black.
I think your eyes are screwed up.
No.
No, like come back here, come back
Yeah,
here.
come back here. And then you have to like bend down a little bit.
Like a fake. Like the orange
Correct.
shadow? Yeah.
No, you need to get lower. Do you see it?
No.
There's an orange shadow.
Yeah,
There it is.
You guys, I think
I see it on this one too.
you're just playing tricks with your.
No.
No, that
No.
one is fine.
100% there's a shadow.
Yeah.
Okay. X is less than negative square root of 5 or greater than square root of 5. Okay, we're kind of running. I want you guys to try some of your own. So